बिस्मिल्लाहिर्रहमानिर्रहीम अल्लाहुम्मा सल्ली अला सय्यिदिना व मौलाना मुहम्मदिन व अला आलिहि वसल्लम अल्लाहुम्मा रब्बि ज़िदनी इल्मा अल्लाहुम्मा रब्बना आतिना फ़िद दुनिया हसनतन व फ़िल आखिरति हसनतन व क़िना अज़ाबन्नार आमीन। अल्लाहुम्मा सल्ली अला सय्यिदिना व मौलाना मुहम्मदिन व अला आलिहि वसल्लम अल्हम्दुलिल्लाहि रब्बिल आलमीन। In this lecture, I will solve S2 of March 2022. Well, all these instructions are very important, especially this last one. Give non-exact numerical answers correct to 3 significant figures or 1 decimal place for angles in degrees. Unless a different level of accuracy is specified in the question, must follow all these instructions. An important advice, we must be good to others. Here are some important tips to solve the exam paper in a good way. Number 1, do neat and tidy work. Number 2, read the questions carefully. Number 3, manage the exam time smartly. Number 4, do every question carefully. Number 5, avoid shortcuts. And number 6, avoid careless mistakes. Well, you can find the link of the math website Math by Sir Qadri in the description, where you can find the soft copy of this lecture. Learn and spread knowledge. Question number 1. The lengths in millimeters of a random sample of 12 rods made by a certain machine are as follows. Part A. Find unbiased estimates of the population mean. Population mean means mu cap, and variance, this means sigma cap square. Well, we can find mu cap with the help of sample mean, sigma x over n. Sigma x of this data is 2398, and the simplified form of this is 1199 over 6. This is the formula of unbiased estimates of population variance. N upon n minus 1 sigma x square over n minus x bar square. N is 12, n minus 1 is 11. Sigma x square of this data is 47926 over 12 minus 1199 over 6 whole square. Hence, the final answer up to 3 significant figure is 2.33. This is sigma cap square. Part B of this question. Give a statistical reason why these estimates may not be reliable because of small sample. The sample is small, only 12 data items. When sample is small, then unbiased estimates are not reliable. Question number 2. Harry has 5-sided spinner with sectors colored blue, green, red, yellow and black. Harry thinks the spinner may be biased. He plans to carry out a hypothesis test with the following hypothesis. H0. Probability the spinner lands on blue is 1 upon 5. H1. The probability that the spinner lands on blue is not 1 upon 5. This not equal sign means the two-tailed test. Harry spins the spinner 300 times. So the distribution is binomial with n is 300 and p is 1 upon 5. H0. This is the value of H0. Use a suitable approximation. This means the normal approximation. Therefore, according to normal approximation, NP is 300 upon 5 and NPQ is 300 into 1 upon 5 into 4 upon 5. So this should be here. This result is 60 and this result is 48. Since the test is two-tailed, so critical regions, there are two critical regions. And the percentage is 5%, so 2.5% is here and 2.5% is here. As the test value is 45, which is less than the mean 60. Since the test value is less than the mean, so you have to perform the lower tail test in two-tail test. Remember this. If the test value is less than the mean, then perform this test. So Z test. Since we are performing this test, so we have to take the upper bound of this 45 after continuity correction. So Z test will be 45.5 minus NP, which is 60, over under root NP cube, which is 48. This is minus 2.093. And Z critical is 1.96. 2.5% of Z critical is 1.96. Since we are performing the lower tail, so it's negative 1.96. As Z test is less than Z critical, that is minus 2.096 is less than minus 1.96. You can understand this here. This is minus 1.96 and minus 2.096 is here. Since Z test lies in critical region, therefore we have to reject H naught. This means evidence that the spinner is biased. Sufficient evidence that the spinner is biased. This is very important, continuity correction. So you have to decide this very carefully with respect to test value and mean. Since the test value is less than the mean, so perform this test. And for this test, you have to go on left hand side. Whenever we go left hand side, we take the upper bound of the test value. You should watch my lecture, summary of testing, on the channel to understand this concept well. Question number 3. A random sample of 500 households in a certain town was chosen. Using this sample, a confidence interval for the proportion P of all households in that town that owned 2 or more cars was found to be this. Find the confidence level, meaning alpha. And we have to give our answer correct to nearest integer. Number 1, we have to find, in fact for alpha, we need the Z value. Unless we find Z, we can't be find, or we won't be able to find alpha. So first we have to find Z, and for that we have to use width of the confidence interval. and this is the formula of the width, 2z ps qs over ns. We need ps. We can find ps by taking the average of these two values, 0.355, 0.445 divided by 2. This will give us PS, the estimated value of PS. Whenever confidence interval is given, by taking the average of the confidence interval, we can get the value of PS. Therefore, PS is 0.4. Width is the difference of this confidence interval. 0.445 minus 0.355 is equal to 2z. We are working for z. PS is 0.4, QS is 0.6, and N is 500. So Z is 2.054. This is negative 2.054 and this is positive 2.054, and we need this area. So alpha is 96%. You all know how to find this area. If you are using latest version of the calculator, then you need to put this as lower limit and this as upper limit, and calculator will give you this area. If you are using the old version, then you should find this area first. This and this, both areas are the same. So when you will subtract these two areas from 1, you will get this area. Next question, number 4. In the past, the time in minutes taken by students to complete a certain challenge had mean 25.5. And standard deviation is 5.2. A new challenge is devised. A new challenge is devised and it is expected that students will take on average less than 25.5 minutes to complete this challenge. A random sample of 40 students is chosen and their mean time for the new challenge is found to be 23.7. So this is the value of H naught. Mu is 25.5 and this is the test value, X bar. And this is the size of sample, 40. Part A. Assuming that the standard deviation of the time for the new challenge is 5.2. Test at 1% significance level whether the population mean time for the new challenge is less than 25.5. Less than means H1 has a lesser sign. And 1% means Z critical is minus 2.326. Well, H naught is mu 25.5, whereas H1 is mu less than 25.5. Now we need Z test. Z test is X bar minus mu naught, the value of H naught, this value, sigma over NS. So X bar is 23.7, H naught is mu naught is 25.5, 5.2 over under root 40. Hence this number is minus 2.189. See, this number is here. This number is not here. It's here. So you have to mention this as minus 2.189 is greater than minus 2.326. Therefore, except H naught. This means mu has not decreased. No evidence that mean time has decreased or mu has decreased. Next part of this question. State with a reason whether it is possible that a type 1 error was made in the test in part A. No, because H naught was not rejected. Because H naught was not rejected. A type 1 error is made when H naught is rejected. So since H naught was not rejected, so type 1 error will not be made. Question number 5. The heights of buildings in a large city are normally distributed with mean this and standard deviation 2.5. Find the probability that the total height of 5 randomly chosen buildings in the city is more than 95 meter. 5 randomly chosen buildings. Total height. So, x plus x plus x plus x plus x. This means 5x. So 5 times 18.3. This is 91.5. Since this 5 is not multiple, therefore we will not square this 5 here in variance. Copy 5 as it is, because this 5 is not multiple of x. We need probability more than 95. Z greater than, in fact, x greater than 95. We have to convert this statement into Z. 95 minus 91.5 under root 31.25. This is Z greater than 0.626. So we need a small area. This area is required. This is 1 minus 5. Hence, the answer is 2.266, correct to 3 significant figures. Part B of this question. Find the probability that the difference, this is very important, between the heights of two randomly chosen buildings. This means h1 minus h2 modulus. Difference means modulus. In the city is less than 1 meter. So we need this probability. So h1 minus h2. First we need mean and variance of h1 and h2. So h1 minus h2. So it's 18.3 minus 18.3, therefore 0. Variance of h1 minus h2 is 2.5 plus 2.5. In variance, we always write positive sign here because variance cannot be negative. This is 12.5. So probability h1 minus h2 less than 1. First write this in this way. h1 minus h2 1 and minus 1. This is the way to remove modulus of this type of inequality. Now convert this statement into z. So minus 1 minus mu, mu is 0, variance is 12.5 under root. 1 minus 0, 12.5. So this is minus 0.0283, 0.283 and plus 0.283. This positive number is phi and this negative number is 1 minus phi. And the final answer is 0.223, correct to 3 significant figures. To understand this concept, you should watch my lecture on linear combination of variables on this channel. I discuss these things in detail in that lecture. Question number 6. In a game, a ball is rolled down a slope and along a track until it stops. The distance in meters traveled by the ball is modeled by the random variable x with probability density function. This curve is quadratic and happy face because of x square, positive x square. So it's a quadratic curve and happy face curve. First part, without calculation, explain why mean is 2. Since we have two values, 1 here and 3 here, therefore mean must be 2, the average of these two. So the reason is, as the curve is quadratic, hence it is symmetrical about x is equal to 2. Therefore mean is 2. Show that case 3 upon 4. This is very simple. For this, all x, use this formula. All x fx dx is 1. This is 1 and this is 3 minus k, and the simplified form of this function is x square minus 4x plus 3. This integration is very simple, so I'm leaving this integration for you. You can do this yourself. Therefore, k is 3 upon 4. Variance. This is also very simple. For variance, first we need ex square. And the formula of ex is all x square fx. So 1 3 x square minus 4x plus 3 dx. So 1 3 x power 4 4x cube 3x square dx. The result of this integral is 21 upon 5. The formula of variance is ex square minus square of mean. So 21 upon 5 minus 2 square, and the answer is 0.2. One turn consists of rolling the ball 3 times and noting the largest value of x obtained. If this largest value is greater than 2.5, x greater than 2.5, the player scores a point. So first we need this probability. So this is 2.5, upper limit is 3, function is x square. Here I forgot to write minus 3 upon 4. Minus 3 upon 4, x square minus 4x plus 3 dx. This probability is 5 upon 32. Since integration is simple, so I'm leaving this for you. You can do this yourself. Now this is known as P, 5 upon 32, and Q is 27 upon 32, and N is 3, and this is of binomial. 3, 5 upon 32, because this probability is constant. One turn consists of rolling the ball 3 times, so N is 3, and noting the largest value of x obtained. If this largest value is greater than 2.5, this will give you P. This is P. Find the probability that on a particular turn the player scores a point. So it could be on first turn or second turn or third turn. So we need this probability. This is the requirement. On a particular turn means either on first turn or second turn or on the third turn. We can find this probability in this way: 1 minus P0, and this is 1 minus Q power N. So we have 1 minus Q is 27 over 32, N is 3. Hence the probability is 0.399, correct to 3 significant figures. Last question of this paper. Question 7. Two points A and B each contain a large number of fish. It is known that 2.4% of fish in pond A are carp and 1.8% of fish in pond B are carp. So both are binomial. 2.4%. Random samples of 50 from A. This means binomial. N is 50 and this is 0.024. 60 fish from pond B. This is also binomial. 60 comma 0.018. Use appropriate Poisson approximations to find the following probabilities. The sample contain at least 2 carp from pond A. At least 2 means this. The word and means multiply. And at least 2 from pond B. So we need these probabilities. We can suppose this as x and this as y. So at least 2. First we need NP, lambda. So lambda for x should be NP, which means 50 into 0.24. And this is 1.2. Lambda for y is 60 into 0.018 and this is 1.08. Now probability x greater or equal to 2 means 1 minus 0 or 1. This is also 1 minus 0 or 1. So 1 minus e power minus 1.2. 0 means 1 and 1 means 1.2 power 1. 1 minus e power minus 1.08. 1 plus 1.08. Therefore, the final answer up to 3 significant figure is 0.0991. Part 2. The samples contain at least 4 carp altogether. Altogether means total. The sum. So lambda 1 plus lambda 2 is 1.2 plus 1.08 is equal to 2.28. And at least 4 means 1 minus 0, 1, 2 or 3. So 1 minus e power minus 2.28. 0 means 1, 1 means 2.28 to the power 1. 2 means 2.28 square over 2 factorial and 3 means 2.28 power 3 over 3 factorial. 0.197 is the final answer up to 3 significant figures. Part B of this question. The random variables x and y have the distributions Poisson. So this is x and this is y. It is given that we have 2 conditions and we need the value of k. According to first condition, we can write x0 means e power lambda, e power minus lambda, and this is e power minus mu, and this square is here. So e power minus lambda is equal to e power minus 2 mu. This is because of rules of indices. You have to multiply 2 with mu. Since bases are same, so we have lambda is 2 mu. Second equation, probability x2 is equal to k times probability y is equal to 1 whole square. So x2 means e power minus lambda, lambda square over 2 factorial. Whereas probability 1 means e power minus mu and mu power 1 over 1 factorial. Now we have to put the value of lambda here. So e power minus 2 mu, this is 2 mu whole square over 2. 2 factorial means 2. This is e power minus 2 mu, mu square, and 1 factorial means 1. So we have e power minus 2 mu, 4 mu square over 2 on left hand side, and mu square e power minus 2 mu times k on right hand side. We have to cancel this with this, mu square with mu square. So we have k is 4 upon 2, which is 2. So this is over. This was the last question of this paper. An important advice: be well mannered. All the best. Allah Hafiz.